Hi guys, today's exercise is slightly different because instead of just solving and doing some calculations, given the condition that we are working in a triangle, here we are going to define the triangle's type. So here we are not only working with the angles of the triangle, but we are searching for its type. We are given that we need to define the triangle's type if we have the identity true for the triangle. Sinus square alpha plus sinus square beta is equal to sinus square gamma. Given that this identity is true for this triangle, find and define the type of the triangle. The things that we should know are the main properties in triangle. The first is that the angles in it add up to 180 degrees, which is written right here. The second is that if we want to present one angle, we can do it as 180 degrees and we subtract the other two angles, the sum of the other two angles. And if we want to represent two of the angles, we just subtract the third angle from 180 degrees. So starting off with our identity, sinus square alpha plus sinus square beta is equal to sinus square gamma, how we can understand, how we can know what's the triangle. Firstly, we have that gamma is equal to 180 degrees minus alpha plus beta. This is already true for every triangle where alpha, beta, and gamma are angles in this triangle. So therefore, we have sinus square alpha plus sinus square beta is equal to sinus square of alpha plus beta. Now, we know that alpha plus beta, which is squared, this is squared. Because we are given that it's squared, we are using the so-called algebraic identities, or also called the special products formulas. And here we have especially the formula alpha plus beta squared. A plus b squared, no alpha plus beta, sorry, a plus b squared, which is equal to a squared plus 2 times ab plus b squared. This is the basic formula, and it's used for easier multiplication, So starting off with this, we can directly apply it to the sinus sum, and what's more interesting is that here we combine two things. We combine this algebraic identity with the formula for the sum of angles when we have sine. So we have the sinus formula for the sum of two angles, which is equal to sinus alpha times cosine beta plus cosine alpha times sinus beta. This is obligatory to be known from students that are learning mathematics here in Bulgaria. So we are studying this in 11th grade, and we are obliged to know it till the end of the year because it's part of our it's part of our mathematical preparation. So we combine the two formulas. The first thing is to actually expand the formula. Sinus square alpha plus sinus square beta is equal to sinus, and here we put everything in brackets, sinus alpha times cosine beta plus cosine alpha times sinus beta, and the whole thing to the power of 2. And now this term plays the role of A, and this term plays the role of B. And we are using this identity, This is one of the basic mathematical identities. So sinus square alpha plus sinus square beta. Sorry for the notification. It's from my phone. And we are having sinus square alpha times cosine square beta plus 2 times sinus alpha times cosine beta times cosine alpha times sinus beta plus cosine square alpha times sinus square beta. So we directly applied the two formulas. First, the formula for the sum of angles, and then the formula for for like the formula for the abbreviated multiplication. Now continue with the next thing. And what's the next thing? The next thing is to present the cosine values using sine values. For example, these one. So we have sinus square alpha plus sinus square beta is equal to sinus square alpha. And from the main trigonometric identity, which states that sinus square alpha plus cosine square alpha is equal to 1, we can present one of the trigonometric functions sine and cosine through the other. For example, cosine square beta is going to be 1 minus sinus square beta. This is the way we present it. Here 2 times sinus alpha times cosine beta. Here we can't present them because they are not having a degree. Plus 1, here cosine square alpha is going to be equal to 1 minus sinus square alpha, yeah, times sinus 2 beta. And this is the way we present it. And now that we have this way, what we are doing is this thing. Notice that we can release the brackets here and here. So let's release them. Sinus square alpha plus sinus square beta is equal to sinus square alpha minus sinus square alpha times sinus square beta plus 2 times sinus alpha times cosine beta times cos alpha times sine beta plus sinus square beta minus sinus square alpha times sinus square beta. And now what we can notice here, we can notice that we have sinus square alpha here and sinus square beta here, yeah? And also we have the same thing here, yeah? So they're just simplifying, yeah? They can be simplified. We can just remove them because this will come with opposite sign here and this as well. They will be moved to the other side with opposite sign. Therefore, we basically subtract them. So we just remove them, yeah? And what we now have that is remaining, we have that 0 is equal to minus 2 times, I forgot the 2, minus 2 times sinus, no, I haven't, it's a different thing. 0 is equal to, 0 is equal to, see this. We have minus sinus 2 alpha times sinus 2 beta, and here we have the same thing, minus 2 sin alpha, sinus square alpha times sinus square beta. So basically it's 2 times sinus square alpha times sinus square beta, and plus 2 times sinus alpha times cosine beta times sinus beta times cosine alpha. The next thing that we can do here is actually to put under a common denominator, not denominator, to to choose a common multiple, and the common multiple is 2 times sinus alpha times sinus beta. Yeah, so we are putting in front of a bracket. Sinus alpha but before that, we're having these, yeah? This is our exercise until now. Here we can divide everything by 2, so it will be easier for us, yeah? 0 is equal to minus sinus square alpha times sinus square beta plus 2 times sinus alpha times sinus beta. Let's write it more clear, cosine beta times cosine alpha. Now this is our, without the 2 here, without the 2, I wrote the 2 again. So this is our common multiple. This is our common multiple here. This and this, yeah? But this is not the common multiple. This is the common multiple. Common multiple. So 0 is equal to minus, or let's do not put the minus, sinus alpha times sinus beta, in brackets cosine beta times cosine alpha, minus sinus alpha times sinus beta. From here, yeah, we have one more sinus alpha and one more sinus beta. Here we can rearrange them. 0 is equal to sinus alpha times sinus beta times cosine alpha times cosine beta minus sinus alpha times sinus beta. But this is something well known in mathematics, and this is actually the formula for the sum of the angles when we have cosine alpha plus beta, yeah? This is the formula. This is the formula for cosine alpha plus beta. So what we obtained is the formula itself. So we just substitute with the formula. Sinus alpha times sinus beta times cosine alpha plus beta. This should be equal to 0. Let's write it like that. Sinus beta times cosine of alpha plus beta is equal to 0. So this is our final line. And now, how we define the type of the triangle? We conclude to something like that. This is our last line, yeah, of the exercise. When we're solving these exercises, we obtain just 3 multiples, yeah? And how we define the triangle's type? We know that in triangle, the angles are always different from 0, yeah? Therefore, A times B times C is always different, is equal to 0 when at least one number of the 3 is equal to 0. Therefore, A is equal to 0 or B is equal to 0. Yeah, this is a well-known fact, yeah. So let's think of it like that. Let's check. If sinus alpha is equal to 0, when we have the trigonometric table, we know that sine is equal to 0 only when we have alpha to be equal to 0 degrees, 180 degrees, and 360 degrees. But in triangle, nothing from the tree is possible. We can have angle equal to 0. We can have angle equal to 180. This is even out of our possible maximum, because the maximum is 180 degrees. So this is not possible. Therefore, sinus of alpha is different from 0. Let's check the same for sinus of beta. It's the same as sinus of alpha. Beta is equal to 0, 180 degrees, 360 degrees, which is not possible in triangle. Not possible in triangle. This is not possible. Therefore, sinus beta is also different from 0. And now we have one last multiple, and this is cosine alpha plus beta. So cosine alpha plus beta to be equal to 0. Alpha plus beta should be equal to 90 degrees, yeah? Because cosine alpha plus beta is equal to 0 only when alpha plus beta is equal to 90 degrees or 270 degrees. Because this is not possible in triangle, we remove this option and we remain only with the option alpha plus beta to be equal to 90 degrees. If these two angles are equal to 90 degrees, therefore the third angle, gamma, is equal to 90 degrees. And therefore, the triangle is a right one. So this is how we solve these exercises. We just transformate the identity until we reach a point where we have three multiples. And then, for this condition to be true, for this expression here from the left side, a to be equal to 0, the only possible way is one of the three things, one of the three multiples to be equal to 0. And this is only possible for alpha plus beta equal to 90 degrees. And therefore, if the two angles in triangle are equal to 90 degrees, the third angle is also equal to 90 degrees. And therefore, the triangle is a right one. Angle with one right triangle with one right angle is a right one. So this is a very, very interesting exercise. And yeah, I hope you liked it. See you in the next video.